All right. I guess I'll have to see what OpenWhisk is then. Oh, well. Sweet. So, morning, everybody. My name is Rana Kraitata. You can call me Ron. And today we're going to talk about the serverless framework and how we can use that to deploy our Lambda functions and create all the possible triggers that it needs to with just a simple command, serverless deploy. I was going to show this, but Afonso did this yesterday. So this is basically a no from him. So I'm going to use this one instead. It's a sticker I really like. And it holds true. I also have it in the back of my computer. But, all right, so I'm going to get started with talking about AWS Lambda. Just a quick overview, and then I'll show you guys how to create one and how to use it. And then we're going to move forward and see how tedious that was compared to how serverless will do it for us. So let's couple quick points about AWS Lambda. It is, these are quick bullet points to describe it. So standalone scripts, they're functions that sit on AWS and they get triggered using events, but they just sit there idly until an event comes in. And that's where the second bullet point comes, event-driven execution. These events, triggers, so to say, it can be multiple types, multiple kinds, and multiple per Lambda. Some examples are API gateways, so if an HTTP request comes in, it'll trigger a certain Lambda. If SNS, the simple notification service from AWS, gets a topic where the notification hits, it'll trigger this. S3 bucket changes, Dynamo changes, et cetera, et cetera. And I'll show you all of these when we get to the AWS portion. No infrastructure to manage, which means that as soon as your code is up there in AWS, it'll just run, trademark. But you don't have to set up your server, you don't have to set up an Ubuntu instance, you don't have to set up Nginx in front of the API gateway. You don't have to set up, RabbitMQ for your messaging service. It'll just work with AWS's platform. Oops, sorry. Built-in auto-scaling, which means that when it doesn't have a request coming in, it'll just sit idly with one version of that Lambda. But as it gets hit with multiple requests at a time, you can shoot up to a maximum that you decide per Lambda. So you can have multiple versions of it running at the same time, and then it'll descale back to the one after the traffic is all gone. So if you're a real estate company and your main traffic is from 8 to 5, after that you want to pay for the resources, post 8 to 5. So Lambda would work pretty well there. You'd only get charged for the time it was used. Logging and metrics are integrated, which means this CloudWatch, so whenever you log stuff from Lambda, it'll go straight to CloudWatch logs, which is AWS's version of logging. You can add metrics around that too to measure error rates, to measure concurrent connections, et cetera, et cetera. So in short, AWS Lambda is a compute service which is serverless and runs in response to events from the AWS ecosystem. It's a quick way to remember it. Let's go through a couple common use cases just to show you guys what it means to be a trigger for Lambda. So you've got some front-end code sitting in S3 that gets shown on a page when a user clicks on it. And then the user wants some more dynamic information like local weather updates. So they make a request for that. It hits the API gateway. API gateway then triggers the appropriate Lambda. The Lambda fetches data from, say, another API, weather.com, or Dynamo if it's stored there, which in this case it is, and returns it all the way through the API gateway back to the user. All of this it's basically an HTTP server, but you don't have to set it up. You just have a Lambda sitting in there, API gateway, and Dynamo database with the stuff in S3. The same way with the mobile stuff. You've got a person sending status updates to another person, and that'll go through our API gateway, trigger a Lambda, and then send a notification to the other person who got tagged in, say, a status or something. Let's see, thumbnail creation. This is, so the S3 bucket update. If the S3 bucket gets updated, trigger a Lambda, or trigger multiple Lambdas actually. In this case, we can have 3 Lambdas, one that says create one for desktop, one that says create a small one for mobile, and one that says create a medium-sized one for iPad. And all 3 will get triggered. They'll all create their own version of the image and then store that wherever you want to store it. And this one is a Kinesis stream. Data comes into the stream and it triggers the Lambda function. The Lambda then processes from the stream and does whatever you need to do with that data, which in this case is reporting. Cool. So now I'm going to try and show you guys how you go around to creating a Lambda function. Ooh. Before that, let's see. This will keep running on the side. Okay. So let's go to the console first. Oops. So whenever you go to AWS's console, this is the first page you'll see. It's a quick way to get to a bunch of places. You can search for what you want to do right here. So in our case, we'll go to Lambda, which I also have pinned up there, but Lambda, and we'll try and create a function. Generally, you have some blueprints over here that you can choose, and they're also based on language. In our case, we're going to use 4.3 because it has a little bit more templates than 6.10 does, since they just released 6.10, or support for 6.10. And we're going to use SNS message. SNS is that simple notification service we talked about, and I'm going to send a message through SNS to come to our Lambda, and the Lambda will get triggered. So you set up a trigger here. These are the other triggers you can set up for Lambda. So you've got AWS, Alexa, or IoT logs, events, DynamoDB, Kinesis, S3, and SNS. I'll enable this trigger, and I'll read from the test topic, which I have created up here. So that's the only topic around. So that's the one we'll use. Whoa, did I delete that? I guess I did. SNS message, enable trigger. We'll go next, and this is the place where you get to put in your code. So I'll just say this is a SNS test topic listener. The function is pretty simple. It reads the message that comes in and logs the message, so we'll see this in CloudWatch, and then displays the message as a result to whatever's calling this function. Give it a name, you give it a description, tell it a runtime. Basically this is the IDE for coding in AWS Lambda, so this is going to get really tedious just using a small WYSIWYG, and it's also a gigantic one-file thing. We'll get into how we can avoid that later. You can set up environment variables right down here. Index.handler, this is your entry point into the Lambda function. So the entry point into any Lambda function is the .handler, or you can decide to do anything different here, but the convention is to use a handler function. An index is basically going to be the name of the file that they choose to name that little code snippet. Roles, AWS is really big into security roles, and as they should be. So I've got a couple created here. One's just Lambda basic execution. It'll run the basic stuff without having to ask for sudo permissions every time. The rest of this is a couple advanced settings. No need to worry about that, like VPC and memory limits. And then you hit next, it'll come over here. You can hit create function. Finally, we're there. The function is created. All right, you can see the trigger is test topic. The code's sitting here, and there's monitoring. So I'll click on view logs in CloudWatch, just so we have CloudWatch on the side here. It says there's an error because there's no log streams just yet since it's not been activated, but we'll try and publish a topic to test topic. Just generate a JSON message here that says name. We'll generate JSON. Generally don't need all of this, but unclicking all those boxes gets to be a hassle, so it's fine if you send all these messages together. And that should be sent. We'll go to search log groups here. Hopefully this will not prove me wrong. No, live coding, please. The bane of any presentation. Oh, hey, there you go. Cool. So we got our event. It's at 12:42:07, 12 meaning, well, I don't know, it's 3 hours ahead of us, or 4 hours ahead of us. Oh, yeah, it's UTC. There you go. Thank you. That's right. Forget I said that. Let's gloss past it. So yeah, and here you see the message that we got from the SNS service. So imagine SNS is another service of yours that pushes stuff to there, like when a transaction gets created in your system and you want to run a Lambda function against the transaction to say integrate it with a third-party company, you can do it that way. So whenever events get fired, you can do something else. That's the simple SNS listener. One more thing I'll show you is the API gateway Lambda. Now this is going to be a very cooking show-esque thing where I show you guys halfway through to creating this, and then I'll give you guys a finished product so I don't have to code in front of you. So we'll get started with this guy here. It's a simple, just get a name from the query string parameters, or see if query string parameters exists, and then if it does, get the .name variable from there. If that's there, use that. If it's not, use world. And just send a response that says status code 200 headers, and send the message saying hello with the name there. And yeah, so this function is currently running. If we look at triggers, we'll see that it runs off of the API gateway. So I'll click on this guy, which will take us directly to, I should have opened a new tab. Oh well, I assumed it would open a new tab. But right there, we have an endpoint that gives us back hello world. If I add a query string behind this saying name equals Ron, it'll come back as hello world, or hello Ron. So this is the API endpoint too. Pretty easy to set up, pretty nice to have just endpoints you can hit without having to set up a server, without having to set up Nginx in front of it or Apache in front of it, and have the code running, have the ports measured out. The usual hassle behind setting up servers. Sweet, all right, but now you may think this is awesome. I hope you're thinking this is awesome, because it really is. It's a huge step forward. But these are the steps we took to get to where we are. We had to log into AWS, create a new Lambda, figure out the triggers, configure the Lambda security, which it was created for us. That's great. Generally, it'll be created for you too. But if it's not, that's a whole added step. Edit your code, the best part, and then publish. And then hopefully it works. You can't know because there's no local testing. So these are some of the drawbacks. I should have put drawbacks on top of there. But the WYSIWYG lacks basic IDE functionality. So if you decide to use the WYSIWYG to write your code, you're going to be lacking in terms of IntelliSense. That it had syntax coloring, but autocomplete for some stuff. Making sure that it having a compile check behind it for languages that are not Node and Python. One file. So if you wanted to, if you wanted to write a big project, this thing would get like 5,000 lines long. You don't want that. And no local testing. So you can't test that locally. You'd have to test it after publishing it and then either putting a test example into the Lambda console or just trying to hit it through an API from somewhere else. Also, yeah, you can zip up the files. One other way of putting stuff in Lambda is zipping it up and then tossing it all up there, which is also a hassle. But in comes serverless. Now this is the pain point here for the guy that made serverless, Austin Collins, I think, was that it was really tedious to make, update, and maintain Lambdas. So and his idea was to create an automated framework that allows you to just write your code and worry about the creation of it later, or worry about the creation of it never. Just create one file and it'll take care of the rest of it for you. So in this presentation, we'll just focus on AWS Lambda, but it also supports, like I said, Google Cloud Platform, OpenWhisk, and Azure. But serverless is a command line utility that takes the overhead of AWS Lambdas and its triggers and automates it, which we'll get into examples in a little bit. I hope that was not mine. But let's see. Under the hood, what it does is it'll just zip up your files as usual, create a CloudFormation script. CloudFormation is AWS's templating and scripting service, I guess. It allows you to create multiple stacks, update your stack just from this one little script instead of having to click around in the AWS console, which is pretty great in and of itself. And then executes that CloudFormation script on AWS. Yeah, I think we can move forward from that one. Cool, so now we're going to talk about creating a simple hello world using serverless. So world, cool. Before I do that, I'll show you guys how to create that. So how do you get around to using serverless? First off, you start by installing it globally. So npm install -g serverless, and you'll have it on your machine. And then as a command, so right there. And serverless is one of the commands you can use. We'll use that to we'll create a serverless project using a template this time around, just to make it easier. So we'll have serverless. Also for the lazy, you can just type in SLS, which is definitely me. and then create, you give it a template name, say AWS is Node.js, give it a path, and the path means the directory you want to create. Or if you don't give it one, it'll create it in the same directory. You hit enter, it goes through, whoops. Oh, I guess I forgot to delete it the last time. All right, and there it is. It creates the directory for you. If we go in the directory, we've got two files, handler.js and the serverless YAML. We'll open those. So handler.js, pretty simple. It's the basic, it's the static code we had in the Lambda that requires an API gateway. It just says, return a response that says, go serverless with the 200 on top of it. And it also returns the event, just to show you guys what is contained in that event variable. And then you have the serverless YAML. This is where the magic happens. This is the one file that you get to manage, and then serverless converts this into a CloudFormation script, which will then run on AWS and create all of these Lambdas for you, all of your resources, et cetera, which we'll go to in a little bit. I'll change this guy. This says 4.3, you can change it to 6.10. Nope, not 7.10, 6.10. But yeah, this is the name of your service, also the name of your CloudFormation script at some point. A lot of this is, so yeah, as we go, I'll try and delete the comments to show you how little is in this. There's a couple standard variables like stage and region. You can change these by using stage and region inside your provider name. IAM role statements, like I said, AWS is all about its roles and security and whatnot, so it's nice to adhere to that. Environment variables can be set up right through your serverless YAML, and you can choose what to include and what to exclude. This is the Lambda part, right? Functions is where you define your Lambdas. So here we're just saying we have one Lambda called hello, and its entry point is handler.hello. Handler is the file that we have up there, and .hello will be the function inside of that module. The rest of this is the other events. No one saw it. The other events you can have like HTTP, S3, you can have schedules. This is basically a cron. SNS, etc. We'll get to these because I have some examples for that later. And this last part is setting up your resources like Dynamo, setting up an SNS queue if you want, or SNS topics, setting up SQS queues. All of that can be done through there. But all in all, this is your serverless file for just a simple setup for that. We'll add an event here, so events, HTTP. I hope this is. Totally forgot that you had to do that. And HTTP path and then method. So path will be just straight /hello, and method will be get. We can type in SLS deploy here. Whoops. Man, you know, it works every time you try it, and then you come here and it doesn't work.
Get rid of that dash before then.
Yep, that's the one. Thank you. And we'll push this. Creating stack. So this means, okay, so now this has created your CloudFormation script. Now it's running that CloudFormation script on AWS. The next time I do a deploy, I'll use verbose to show exactly what's happening behind the scenes. It basically goes around and creates the Lambda, creates your IAM roles, creates either any SNS triggers you needed, any API gateways you need, stuff like that. Sometimes it takes a while, especially for the first one. The first create does take a little bit. But after this is done, we'll test it real quick, and then we'll go to using, where's this guy? The other one that I have set up, so git checkout. I hope this is, yeah, hello world. Oh, and that's, yep, that should be done in a little bit. I still couldn't figure out how to spend my time when this is deploying during a talk. It's like I'll just stand here awkwardly and wait for it to get done. Scratch my beard.
I've got a question, Mark.
Oh, you know what? How did I not think of that? Yes, yes.
Let's say, so I haven't used Node a lot, but could you include like a Node module? Like let's say you want to have a Lambda to process video files. Could you include an FFmpeg Node module or something?
Absolutely. We have that in the other one as soon as this deploys at some point. So the other guy I have is this one here. And you have a bunch of Node modules that you can npm install it, and it'll just push all of that together to serverless. You can also choose which ones to include, which ones to not include. Generally, it'll zip that up for you, so it'll be tiny enough as it is. But yeah, yes, you can include node modules with that. What are you doing? Sorry?
The key is to send them with the function.
Yeah, precisely. Yeah.
Lambda will not run npm install. You have to npm install, zip it up,
And send it. Yeah. All right. This is killing me right now. All right. So let's see. Over here, I have the other one set up, and this one still has the same serverless as before. Oops, I should have. This is ruining my secrets. All right. Right here, we have the same function as before. It is name. So the same thing we had in Lambda, but now it's in our repository. And sweet, that one got done. So I'll switch to serverless to-dos. Cool. So this is the folder I want to be in. I'll deploy this guy too for now, and we'll test this one here. I hope that one works. And right here. Oh yeah, I'll show you what I did. It's just right here. So what this thing tells us is it got done creating our API gateway, and if you want to hit our function, we can use this endpoint here. You can prettify these by going into API gateway inside AWS and adding a custom domain around it, which I'll show you in a little bit, but I don't have one to put in there, so we won't get that far. /hello, and you send that. I'm using HTTP instead of curl because I just like how it works. And you pass in your URL at the end of it. It comes back with the event. So all of the stuff that's inside of it is inside of the event variable shows up here. And then we have our message at the end saying, go serverless, your function executed successfully. This is, again, taking its time to do this. But yeah, cool. So in, 3 minutes, excluding the overhead of the deploy thing, we got a API gateway set up and a bunch of endpoints up there. It is really nifty to use, and I've really enjoyed working with this. And once this is done, we'll then move on to trying out the hello world with this guy, and then we'll go to create using to-dos. So I created the obvious to-dos app with this, with a bunch of CRUD endpoints and using Dynamo in the end as your storage. But while this is deploying, let's have some more questions here. Anyone? No? You guys are killing this idea.
I assume the Lambdas are extremely cheap to run with Amazon.
Yes. The pricing was mentioned yesterday, which I was not paying attention to too much, but it's something like
20 cents for 1 million requests.
that guy. As you can see, I clearly don't deal with billing in Lambda. I just create it and let my upper management deal with the bill that comes in. I haven't been hit up yet, so I'm assuming I'm fine.
And they have a free tier that is 1 million requests per month as well.
Yeah, that's right. That's the one I'm using right now.
So they charge you per request. What if you have a high processing, like a high CPU?
It charges you per request and per duration of execution.
Got it.
We have like 400,000 seconds every month.
But, and this is our hello world one, where the message is just hello world, and if I type in name and my name behind it, it'll come back with hello Ron. So again, a quick way to set up your custom functions and send them to serverless. I'll go ahead and check out the next version of this, which is to-dos. Also, I'll send out a link to the slides after the presentation, and the link to the slides will contain a link to this GitHub repo too, if you guys want to mess around with it. And we'll do the same thing again here, and while that's happening, this time I do have something to show you. So we're good there. Let's see. Oh, this is the wrong one. We'll close this guy. This is the one. So here we've got our updated serverless YAML. This time around we have a bunch of different events to get fired with this. So it's and we're using Dynamo. So let's see what the changes are here. You've got a custom field where you can set up custom variables just for this script. So in my case, I'm using table name here because I want to set this table name as an environment variable for my code to use and as a name for the resources section of my CloudFormation script to use. Plugin is serverless offline. I'll show you guys what that is in a little bit. The same thing here. AWS 4.3, I guess I can change it to 6.10. To-dos table, the environment variable that I can use inside of my code is referenced in that custom area up there and using the name of whatever that was. IAM roles, you set up the roles saying, hey, allow this guy to create, update, and delete Dynamo tables. And then we get to the functions part. The Lambda is now named to-dos. The handlers, of course, get into handler.todos handler. Give it a description, give it a name to make it look pretty on the AWS UI. And then we'll mention the events. So any events that are /todos for get or post, and then todos ID for put and delete, send them to this function, and it'll execute the function behind it. So this is the function behind it. Todos handler. This is a little bit archaic. We could decide to use 4 different lambdas to handle each of these events. But for now, I've just gone with the one lambda. And then just check if the HTTP method says get, post, put, or delete, and whichever it says, follow up with that module. Follow up by calling that module. You generally have callback. Callback is what you would hit as a return. That's your return statement, basically. And it says null would be there's no error, and this is the output I want you to return. Or if there's an error, just put the error in the first field. And this is our code here. Just a simple connection to, so say we're using create. You've got moment, UID. And like you mentioned, the node modules, yeah, you can install them and then package them up together and send it. Set up your Dynamo connection, set up the Dynamo params to put stuff into Dynamo. And right here's your functions, the Dynamo.put. If there's an error, say that, reject with that, or, again, don't judge the code. Or create a response and send that response via resolve on. Yes, and it's done in time. Nice. All right. So we'll try and use this guy to create one. So HTTP, we'll use the endpoint there, and we'll say text is talking at SyntaxCon. Please work. Oh, yes. The little moments of insecurity. You're like, no. But, and as you can see down there, it creates this and tells us it created this guy in Dynamo. If I go over to AWS's console, open up Dynamo, you'll see that there's a table created for us called to-dos. I probably should have shown you guys that it was not there prior to this, but believe me, items, and then our items in here with the checked in, add, modified, et cetera, and barring any time spent on coding that little to-dos app, that's how much time it took to get it up on serverless, is the serverless deploy time. And now we have a database, a bunch of endpoints to hit that database and manipulate the data behind it. And you can see these logs in CloudWatch. But if that's not enough, here's an even better part. Remember when I said no local testing in serverless or in Lambda? Serverless allows that with a couple plugins around it. So let's see, serverless, let's see, SLS. SLS offline. Remember that plugin I mentioned, serverless offline? Yeah, that helps you run your serverless Lambdas locally. So SLS offline start allows you to hit all of these endpoints from your local host, 3000/todos, and you'll see that's a simple get on 3000. Another good part. Yeah, but wait, there's more. I can add stuff to this. This will show in Dynamo, if I can spell it. And this is me testing it locally. That's localhost 3000. I go to Dynamo here, and sure enough, it shows up. So you can test it locally and also have changes show up onto the infrastructure you've set up. So your dev environment is basically AWS now, and you just talk to it through your local host. So I found that pretty nifty to work with. One other thing that I should have been running on the side is there's SLS logs. So you can view those CloudWatch logs right in your terminal by giving it a function name. So in this case, it'll be to-dos and --sail. We'll just open up the CloudWatch log stream for us and show it all right here. So you can follow your logs as you're executing commands. And to complement that, you'll see if you go to the function, the Lambda function called to-dos handler, and the monitoring tab, CloudWatch, and you'll see that it's got the same stuff, except that you have to click on it, and in this case, it just shows you right there. That's a tiny little win, but that's the basicest power of serverless is allowing you to do most of your AWS Lambda stuff from your terminal, so you don't have to go back to the console and deal with it there. And yeah, that's basically the biggest part of it. One more example I have is to show you guys it's just an extra trigger. But apart from that, like this is the power of serverless. So we'll do not get checkout, get checkout, tags, SNS I think. Yeah, all right. Oh, SLS deploy. Oh, that's what I messed that up. Yeah, cool. All right, so we'll talk about this code a little bit. We'll go back to the serverless YAML, and you'll see this time I've added allow SNS. So anything with SNS, anything that has an ARN that says SNS, allow that. Any resource that has SNS, allow that. And down here we've got two new Lambda functions. One is a scheduler. So the first event is schedule and runs at minutes. That's basically your cron job. This runs with CloudWatch events, and it runs at a rate of every minute. Now this is obviously just a show for our case, but say you had to-do notification that you wanted to send out at the end of every week saying, hey, you completed 633 to-dos this week. It's a productive week for you, right? Don't send those are annoying. But if you wanted to, you could do it. And then you have an SNS listener that I just wanted to show you guys that the SNS topic actually got fired. But that's how you would set up your cron job, and the rest of it is just writing your code. So go back to handler here. You can see that module.exports, we've added two new modules, complete handler and SNS listener. Complete handler calls the completed function that gets brought in from source events. And right here is setting up Dynamo, setting up SNS. At the end of it, we just have this guy here that says get num completed, which gets your completed, the number of completed to-dos. I forgot the word to-dos. I've said it so many times. From Dynamo, and also there's a little bit of logic around there saying, hey, just give me the to-dos I've completed in the past minute. So right here, this is just Dynamo's mumbo jumbo. If you want to look at it, you can. But we'll go down to the query, just simple moment usage here, saying subtract a minute, see if it still shows up, and then return recently completed's length. This just tells you how many recently completed to-dos you've had. Take that result, toss it into publish to SNS, where we devise the SNS AWS ARN by using, oh, also forgot this. Another custom variable added was the to-dos completed SNS topic. That adds the topic name. So when I create the SNS topic right here, I can use that there, and I can use it in the environment variable to send to my code. Basic thing, just to keep track of. And then get the message together, send the message using SNS publish, and boom, you'll have that message in your SNS topic. Boom. That's done, sweet, and it tells you the exact functions it's deployed. You can use this name here as your log name, so whenever you do SLS, and I wonder how many times I've said SNS and SLS logs, it'll pop those logs over here based on that function name. Also, I've changed something about this other function because I realized my checked was being stored as a string, so I just changed that to a Boolean. HTTP, this guy, text, oh, whatever, cool. I was gonna say Boolean, but that works too. And as you can see, I changed the checked from checked and true or false because it would still receive as a string to completed and a 0 for a Boolean. But regardless, we created another one, and now I can complete this guy. So HTTP put, oops. Let's go ahead and put the put in front of this, and text is cool. Completed is 1. Please work. Wait, what happened? It's the, I'm using the wrong URL. That's what I get for being lazy. All right. Let's see, get this guy there. We'll use the ID from up here when we created it at the end of this. And then text, cool, and completed equals 1. Sweet, and that tells us, cool, that's updated. Now if I go to the Lambda dashboard or functions, you'll notice we have 3 functions now: to-do handler, SNS listener, and completed handler. We'll go to complete handler. It looks awful when you have those error ticks, but it's just now reset from last night when I was messing with this. All right, and let's see, search log groups. Oops, that's not good. In the past 5 minutes, we've had, all right, well, the execution was at 13:07 and 13:14. That was not done at that point. This one was done at 13:07:27. So we'll have to wait for the next go around, which should be happening. There you go now. And like I said, this runs every minute. So this is the minute it ran on and recently completed as 1. It's running twice because one of them errored out during when it got pushed, but the other one will die out soon. But right here it says recently completed as 1 out of the completed to-dos, and it published without an error, sent it to the SNS topic over there, and the SNS topic received it, and it's all good. I think that was about it for my talk. Let's see. Yeah, creating the CRUD operation, what you need to do is update your serverless YAML to define DynamoDB, update your handler methods to have all the ones you need, and hack away, best part again, deploy to AWS, super easy. Firing SNS using a scheduler. Oh, I added an index to DynamoDB so I could pull via modified at or pull via checked completed. So you need to add that. Add the handlers for SNS and your scheduler to the Lambda. Again, the same basic steps. Update your serverless YAML, write your code, deploy it. Test if you need to. Or you're a rockstar and you don't need to test. Leave it to the QA. Whoa, this is not how I wanted it. You know what? It's fine. It's fine. We're good. So this is just a quick, server versus serverless. It's not a fight. I'm just trying to show you the differences between using these two. So for the server, you'd have to set up your own Ubuntu instance, or you'd probably not be using Ubuntu. I just couldn't think of anything else. Nginx as your HTTP server, Node as your language or whatever you wanted to use. Mongo, RabbitMQ, instead of using SNS, we'll use the message queue over there. But all of this is something you have to set up. All of these are something you have to keep track of. Keep track of their specific versions, keep track of their security patches, et cetera, et cetera. If not you, your DevOps person has to do it, or somebody who's maintaining your servers has to do this. In AWS land, yeah, I did not do that correct. But besides, in AWS, we're just using all of the services provided by AWS. They take care of all this patching. They take care of all the versioning. All we need to worry about is setting up the tables, setting up the topics, setting up the gateway, and writing code. So yeah, that's one of the reasons I really like using AWS Lambda, but my gripe with that was the tedious process of updating it. Serverless came around and really changed my life in terms of using AWS Lambda and the ease of using it. So I'm pretty excited about it, and that's why I wanted to give this talk. So for now, I think we're done with 5 minutes to spare. Yes. All right, let's talk about any questions. I'll tweet the slide out after the presentation.
Yeah, question about the offline. So it looked like it emulated the API gateway, so the local URLs, and it ran the Lambda. But it
Yes.
went after all the other resources to the AWS. What else can it emulate locally?
It can't emulate a lot else. It's just a server that it emulates. But what you can do, and this is a little hacky, but I do use this to do my local testing, is you can change your function, comment out the schedule, and just change that to an HTTP endpoint for a little bit. Just put, instead of this, write HTTP, give it the path, and it'll call that function for you still, just like any other function would be called. If you needed a context, just take the context from AWS for now and toss it in your post method or the post body, and that's how you can get around to testing it locally. And then when you push it, just change it back to your scheduler and push it up to AWS. That's how I'd get around testing some of the other stuff locally. Like if you had an SNS topic come in, sorry, totally forgot. The question was, serverless offline, what else can it do apart from just an API gateway? Not much else, but the idea is that you can convert your triggers to the API gateway for a little bit, and then it'll run that way. So, yeah, no problem. What's up?
What languages is serverless capable support?
The ones I know of are Node and Python. I'm sure I can go to their site and see what languages. C#, Java, yeah, precisely. Most languages that AWS Lambda supports, I think serverless does a good job of supporting too. So yeah, and I think at work we also use it to push up our Java files. So it takes the Scala code we write, turns it into jars, and then we send those jars to Lambda. So I know it supports that one for sure. Yeah, cool, good question.
So it can't tell you version, you're like using version of Node, so you're using a 6 or something, you don't have to like compile it out or anything?
No, AWS recently added support for 6.10 about like 3-4 months ago. But good point, I do use serverless Webpack, which is another thing. I don't want to get too much into the weeds of this, but this is one of my work projects where you can use Webpack to compile your Node code down to 6.10 if you need to. Serverless Webpack I really like because it has its own version of a serve function, so you can test locally using Serverless Webpack without needing to use Serverless offline. But then it takes that, builds the stuff out into Serverless Handler, just one gigantic file, and then sends that Serverless Handler file to Lambda. But yeah, so that you can use Webpack. The plugin is Serverless Webpack, I think. Yeah. And I've enjoyed working with that one, especially because I started this project about 5 months ago, and at the time, there was no support for 6.10, which was slightly saddening, but then I found this guy, and it worked out pretty well.
Do they handle that version automatically, or do you have to set which version that you want?
You can say you want to use 4.3 or 6.10. Generally, I mean, you saw that we had 4.3 up there, and we could still use arrow functions because they do that for you on the server now. Oh, on the serverless. Sorry, I didn't say server. Yeah. But cool, good question. Let's see. Still got a full minute. Anybody else? No? Well, sweet. Thank you guys for coming here. This was a blast for me to do. Thank you for sticking through my first talk. It was a lot of fun for me. I hope it was the same for you. Hope you learned something from this. And the slides will go out on Twitter. You can go check out the GitHub repo from there. Thanks, guys. Oh, wait. Thank you.